Lesson 6.9. So we're going to be solving problems with linear relations. First problem is showing two graphs, Tony and Ivor's, and basically it's talking about basically the distance they went per hour. So I've already completed the table of values based on the distance and the time for each. So just by looking at, they both went for 2 hours, but Ivor went, a lot further. He went 40 kilometers, and Tanya, I said Tony, but it's Tanya's. She went only 16. So we have to write an equation. So the equation here would be distance equals 8 multiplied by however many hours it is in time. So we can see that if she went 1 hour, 8 times 1 is 8. 2 hours, 8 times 2 is 16. So this is good for Tanya. And Ivor, same thing, except every hour he went 20 kilometers. So this is his. So depending on how many hours, you can just multiply by 20 and you'll get the distance. And that's what I did in this next one. So basically, how far they travel after an hour and 1.75 hours. So 1.75 hours is saying an hour and 45 minutes. Okay? So 8 times an hour and 45 minutes is going to be 14 kilometers. Okay? And we can see that here after feet and Ivor, 20 times 1.75 is 35 kilometers. So it says to compare with the graph. So if we look at Tanya's at 1.75, so 1.75 would be right here. And then follow it up, it would be 14, just like we said. Same thing here. Ivor, 1.75 would be right here. Follow it up, 35. Okay, so we were right comparing it with the graph. Okay, so we know that our equation is correct. Okay, on to the next page now. Using your equation, how long does it take the person to travel 10 kilometers? So we'll do Tanya first. So again, now we have to use our substituting for distance. So 10 equals 8 times the amount of time. So what we have to do now, we want to find out how long it takes. So we divide both sides by 8. Equals, 10 over 8 is time, but we can kind of simplify this a bit more. Well, if we just put that in a calculator, we would find out that it's time equals 1.25 hours. Okay, that's how long it would take. And that's an hour and 15 minutes. Okay. Next one, Ivor, we do the same thing. Now we do 10 equals 20 times time. And 10 divided by 20 equals time. Basically, it's going to be 1 over 2 is time. And we know that 1.5 is 0.5 hours. So now we compare the graph. So we said that to reach 10 kilometers, it would take her an hour and 15 minutes, or 1.25. So, oops, that's the wrong page. Let's see here. 1.25 would be here. How far? 10. Perfect. And then for Ivor, we said it would take half to get to 10, half an hour. Perfect. So we got it right here. Those are the correct answers. So one graph models a person training for a long bike ride, and another training for a marathon. Who's who, basically? Who's training for which? So, a long bike ride and a marathon are completely different. Marathon is going to be a lot longer, so we're going to look at the person who's traveling further, and that's going to be Ivor. And then Tanya is just training for a bike ride. Right, in marathon, you're going 40, 50 kilometers, right? And that's kind of what Ivor is doing. Next problem, Sally the saver and Sam the spender. They're comparing bank accounts over time. Sally's bank balance is $275 and she deposits $75 per week. And Sam has $900 and he withdraws $50 per week. So here are the equations. So Sally starts with $275. She's adding $75 more per week. Here, Sam starts with $900, but he's taking away $50 per week. So we have to start with our table of values here. 0 weeks, that's their initial values. We'll do Sally first. You're adding 75 each week. I'm just adding 75 each time. Okay. Now, taking away 50 each week for Sam. So, we have both of our table of values filled out. Now we have to graph it. Okay? So, let's do Sally first. So 0, she's at 275. At week 1, 350. At week 2, 425. Okay, that's I mean, we can continue our line because this can go beyond the 6 weeks we did it for. Now, Sam starts at 900, so he's all the way at the top, and he's taking away 50 per week, so 50 per week. Did 6 weeks, so again we can draw a line. So you can say it keeps going. This one is Sam, and this one is Sally. Now it's saying, okay, when do they both have the same amount of money? It's where they cross, which would be this point right here. And we can even see on our table of values. So week 5. So after 5 weeks, they have the same amount of money. Describe the cash situation over time. So I'm just going to describe it with words. Who has more money and when? So actually I can write it down. So Sally has more money from week 0 to 5, and Sam, said that backwards. Sam has more money. So Sam will have more money, as we can see, is more money from week 0 to 5. They have the same. So Sam has more money from week 0 to 5. Sally the saver, she's saving her money, has more money after week 5. Okay, so week 0 to 5, Sam has more. At week 5, they're the same, and then Sally has more money from week 5 onwards. Okay, we can see that from our graph. We can see that from our table of values. Okay, and that's 6.9.